Excellent. Thank you very much for inviting me. I'm Alex, and I'd like to talk about interface contracts in event-driven micro frontend architectures. So there's a lot to unpack here, right? So we have contracts, we have interfaces, we have event-driven, we have architecture, and lots of things to talk about. So thank you for having this hour with me. I understand you're already building micro frontends, so you will probably see a few things that you are familiar with. You may see things that you are new to you, or you may even not agree with. That is fine. It's architecture. It's all about decisions, trade-offs, options. So hopefully I can give you some options today, and we can later on discuss what you took away, what you'd like to challenge, and what we can take away from this together. Okay. So let's lay this out and start with a bit of micro frontend architecture as such, okay? Because you may be an organization that comes from an architecture where you have your microservices and they are neatly aligned with your domain concerns, and you would have some sort of API layer, GraphQL, something like that. And then in the front end, you would have a single page application of some sort. But now you have a little problem here, because while the backend services are nicely aligned by the domains in your architecture, in your application, in your business model, the front end goes across all of your domains as a monolith, right? And it may be that the front end is modular in a sense that you have components, but it's still tightly coupled through state, for example, through a framework, through a deployment mechanism. And this makes delivery of new features hard, right? So you may have made changes in the back end and already ready for consumption, but if you want to roll this out to your customers, you will realize that you need to get through this monolith with all these dependencies internally. Now, wouldn't it be nice if we could replicate this pattern of isolated services in the front end as well, right? And this is exactly what you could do. You could build a distributed front-end architecture. Instead of a API layer that integrates it, you would have a little integration layer, an app shell, whatever you want to call it. We will discuss this later. But basically, you have the same pattern here now, a distributed architecture. You still have a little problem, though. So while you may have it distributed and easier deployable, you may realize that you still don't have real alignment with the service in the back end. So it may be that you have them overlapping domains in some way, shape, or form, and you still always have to go through this API layer. So that's a valid approach for building micro frontends. It would be micro frontends with microservices, but you could also do something that is a full verticalization of your architecture. And this would be a way to say, I'm building a full vertical. My whole architecture is composed of little applications that have both a front end and a back end. And in this case, you have indeed a full alignment of the back-end capabilities with the front-end capabilities. So the domain logic with the user interface and its logic. You still have a little layer because somewhere things need to be integrated and communicate, and we will discuss later how we can address this integration point and how to slice and chop down micro frontends. Now you might say, well, we still have concerns that cannot be integrated in the front end. You may have things like a authorization, authentication capability. You may need to share data or some sort of event mechanism. And the reality is that in a more complex architecture, you will have this in the what I would call the web domain or web scope, but then in reality you would have a layer of domain services underneath that. So you still would have micro frontends that have their little client-side part and their server-side part, and there's a reason to have that server-side part because it would be translating from the domain services into your UI logic. So this little backend in this case would be a so-called backend for frontend. It's kind of a reverse API, because it does not follow the logic of the provider of data, but the consumer of data in order to prepare things that they run properly in the front end. And you would have in the back end, you could then again go with domain services and expose them through GraphQL, for example. Now you might say, well, isn't that the same thing we saw before? Isn't that a layered architecture? And isn't that, again, the whole thing where you need to go through several layers to deliver value? To some extent, yes, it's true. So this is a trade-off or a kind of compromise between the needs of coherence and consistency across the entire landscape of services. But you will also see that you have very clear defined interfaces here. So first you have domain logic that is in a deeper layer and owned by other people. And you still have a vertical isolation in the front end or in the web domain, right? So it is slightly different, and in a very large organization, this is probably what you would have to do to build micro frontends in an enterprise API environment. Okay. So this is just a more structural view on where micro frontends sit and how you would approach them from a mental model level. Now let us look into, if I say we have those isolated stacks, what that would actually mean. And this would be the part where I talk about AWS, and that's almost the only part. So for those who are fans of AWS, this is the part for you, although it's quite simple because in the end, it is a standalone stack. So what does it comprise? It has a few things in the front end. In this case, you would build your assets statically, deploy them into a S3 bucket, and you would expose them through CloudFront as the CDN, obviously. And there isn't much more than that, so you don't need any kind of web appliance server, anything. You would still have things that run in the back end, but they are only there to either be the full back end source of truth for your micro frontend if you have a full verticalization in a more simple approach, or they would then later integrate with the main services. Then they obviously wouldn't need a database. And the services I have here are more examples, right? So this could be Lambda, but this could also be, I don't know, App Runner, or it could be ECS. I wouldn't go for EKS or a more complex container scenario in this case, but this is just my personal opinion because you want the autonomy of this team. The benefit of this architecture is to have autonomy, fast delivery, and if you're imposing a strong dependency on infrastructure like an EKS, this needs to be a good reason for that and be very carefully handled to not obstruct the team in delivering value. Okay. Now, again, if you put all those things side by side, you may see several of those. It could be dozens or even hundreds of micro frontends. And this sounds like a lot of overhead from the infrastructure perspective. And you may say, well, yeah, the AWS guy tells you how to consume a lot of AWS services. But the good thing is that all of these are consumption-based. So it's not like you're paying for an instance. So all these services are based on the usage. So for example, if you talk about Lambda, it only fires for an invocation. And if you have a Lambda for a very small micro frontend that is only invoked, I don't know, 5 times a day or per minute, I don't know, then obviously it will not create the costs that you would have there. And because the code in this Lambda could be very lightweight, it wouldn't consume a lot of memory for the purposes it serves. Okay, so that is just an example of an infrastructure set up for this kind of micro front-end architecture. The point here is the main takeaway is not funny colored icons, but you would have dedicated infrastructure for each micro front-end, or you could. It is a benefit of a strong separation between not only the logical building blocks of your architecture, but also the infrastructure and deployment process that deliver those. Okay. But then, of course, you will still have those shared concerns, as you've seen in one of the earlier slides. You could then have, and this is just again a very simple example with an API gateway Lambda and a database, where you could say these micro frontends do not only need to communicate in the front end through the events, as we will see later, but there may also be things that need to happen in the back end, such as distributed authentication or things like that. Okay. So this is, again, not a fully defined approach how to build the infrastructure, but just to set your mind to this could be an individual stack that is fully owned by a team end-to-end. Right? End-to-end ownership is the point here. Now let's talk a bit about the composition of such micro frontends, because in the end, it is a web architecture. It has front-end in the name, so let's look at some UIs and think what is actually a front-end, a micro front-end. Right? So, and when we look at an example application, so in this case, you see a flight search page. Imagine this is a touristic website, and they offer you to book flights, and you could decide to split this in some way or not to split it. And the million-dollar question here is, where are the context boundaries? So context boundaries is a term from a paradigm called domain-driven design. Have you heard about this paradigm? Who has worked with domain-driven design or applied it or is familiar with the concept? Okay. So the idea behind domain-driven design is that you would structure your application into domains and subdomains and identify bounded contexts. where you have a certain domain, language, and logic within those contexts, right? And this is a pattern that is very applicable to micro-frontends or any type of microarchitecture, because it's very helpful to understand where are the things that need to be carved out and isolated and would then be loosely coupled with other building blocks. And the biggest question here is, how do I cut this? How do I cut a monolithic backend? How do I cut a monolithic frontend into pieces that don't create more communication overhead than necessary? And the aspects we use or the measures we take to make this decision could be non-functional requirements such as security, authentication boundaries, performance issues. But in most cases, a good decision mechanism to say what belongs together, so to speak, is communication patterns, right? So what needs to talk a lot with other things in simple terms. And there is no right or wrong here, that's the thing. So I've had this conversation with product owners, with testers, with developers, with operations people, and some people say, the whole thing is kind of a micro front-end. It's micro enough, it's a page, right? It has some business logic, kind of everything belongs together, so this is my micro front-end. Why not? There are implications to making this decision, but you could legitimately say this is your kind of micro front-end scope. Others, especially if you ask UI designers, they think in very small building blocks and modules. They would be tempted to say, yeah, but every of these items is kind of a micro front-end, right? We say micro, so it needs to be small, and I think this is the smallest I can think about when I look, or it's the largest I can think about, so I wouldn't make it larger than that. That is my micro front-end with all these three distinct elements of search bar, filter, and result list. And I would propose for this talk we take the middle ground, right? So we say we have two micro front-ends. This is just me being opinionated. You would have the filters at the top being one micro front-end, and you would have, sorry, not the filters, the search bar at the top being one micro front-end, and the filters and the result is the second micro front-end. Why? Because you could use all of those standalone. You could have the search bar on just a single standalone page and have this as a landing page for something, for a campaign, for example. Or you could have the filters plus the result list on the page and say this is kind of a standalone campaign page where people get results immediately without invoking a search. I wouldn't separate the filters from the results because filters don't make sense standalone. They are just a dead component without any logic. So I would rather have it built in a way that you can show or hide the filters and have the thing called the results micro frontend. Okay. This is my approach, but you could legitimately say in your situation you take a different approach to slicing. Ideally, you would have a architectural decision log or something in place to say why you made this decision and what you have considered else. Okay, so for the purpose of this talk, keep in mind we have two micro frontends. We will later see how they can communicate. Now, before we go to the actual communication of micro frontends, I would like to make a little kind of turn around and talk about a very popular but often difficult to understand, let's say, architectural pattern called event-driven architecture, or EDA. Who has built EDA applications here?
Entire e-pilot team.
Sorry?
Entire e-pilot team.
Okay. Wow, okay, so I need to be careful now. All right.
We'll be watching.
No worries. So, I'm basing this on a book and a website called Enterprise Integration Patterns by Gregor Hope. Anybody read this one or has used this as a reference? So this is more than 20 years old now, but it still is a reference for basic terminology and concepts around event and message-based architectures. Now, the one thing we don't want to have is something called integration spaghetti. So it's a spaghetti architecture in a distributed or integrated architecture. I don't need to say that we don't do it, but why don't we want it? It's because we have different types of coupling here. And coupling is not necessarily a bad thing, because in the end things need to work together, need to be coupled in some way. But we need to be aware that coupling one piece of software or logic to another one influences that and makes the architecture more rigid. And there are several types of coupling, right? So you have things like temporal coupling, semantic coupling, location coupling, and this kind of quote-unquote distributed architecture would have several types of coupling here that would in the long run obviously obstruct the further development of this application. So you have mainly two types of coupling here that event-driven architecture addresses, and this is location coupling. So each service needs to know where each other service sits in order to communicate and get something done. And you have temporal coupling here. This is not obvious from the arrows, but in many architectures you see that you have a lot of synchronous traffic, right? You talk about REST or GraphQL, and these are synchronous paradigms typically where you would send a request and expect a response, hold the connection open for that time, and block the resources. And that is the problem. That's the main problem that EDA addresses, that you will create a lot of coupling, but also create a lot of blocked resources. While you scale, this will become a problem. So EDA at its core is built around the concept of a message broker. And I'm losing the term broker here. I will not go into the semantics of the difference between a broker and a bus. But the point of the broker is to transform this spaghetti architecture into a so-called hub and spoke architecture. So you have one central point of information, infrastructure, and all information between services would flow through this central service. Of course, you can now argue this is a single point of failure, but so is every service in this other architecture, right? So if one breaks down, everything breaks. So you will have to apply patterns to make your architecture resilient, like circuit breakers and things like that. But in theory, you solve the problem of temporal coupling here and of location coupling. So you don't need to know where other services sit. And if we go into message-based communication, we don't care about an immediate response. This will come otherwise, come around. Okay. Now, the broker itself is an abstract concept. It has no notion of delivering messages as such. And obviously, in a real-world application, we don't want everything to talk to everything. This is first from a security and scoping perspective, not a good thing. Again, we introduce coupling if we don't know who listens to what. And so you want to have something that's called a router inside your architecture. We will get to microfronts back again, so we're not completely lost. It's just a foundational concept to understand why we're doing things in a certain way. So the router has rules that are built or implemented on the router to say where messages go. You could also have an alternative pattern in the broker, and this is a publish-subscribe pattern. So in terms of communication, either you have the logic where messages go in the router of the broker, or you would say the broker is just a mechanism to hold and accept messages, but if somebody wants to read those messages, they need to subscribe to a topic in that broker. Okay. Now if we zoom into the individual communication between two exemplary services, let's say we have an e-commerce application with an order service and a payment service, then you might want to put them in such an EDA and say, okay, we are using a broker with a router, and I expect that something is being, when the customer completes an order, then the payment is being processed to collect the money. And you could achieve that by sending, saying the order service knows when things happen. So the order service would simply say, I will please get the payment, and it kind of emits a get payment command. Now this is a message, but it's a command message, and this is a bit of a problem because that's not really event-driven, right? It's command-driven. You impose the ownership of the communication on the sending side, and basically don't leave the follow-up building blocks the autonomy to decide what they do with that. So you need to turn this around and say, instead of a command, I need to send an event. And this is a very important distinction between other types of message-based applications, is that you don't send things that others should do, but you tell about your own history, right? So I think when you work with EDA, this is hopefully understood, but it's a very important distinction, is not only just send a message, but be very clear about the semantics and the notion of these messages, right? So now we have said we have our broker with the router, but we could also have the same thing. And this is called the, sorry, missed that one. So this is called the choreography pattern. So this is a distributed architecture where the logic of distributing messages would sit either on the broker or in the service themselves. Alternatively, you would see this pattern also being applicable with publish-subscribe. So you could say, again, I have the order created event, but instead of the broker knowing where to send it, you would let the payment service say, I'm listening for orders to be created, and I will go run and pick a payment whenever I've seen this come in. Now, the choreography pattern is great in situations where you have larger building blocks or very distinct applications, when they themselves have the integration when they own the integration with another part. In smaller, more coherent microarchitectures, such as microservices or also micro frontends, the problem with orchestration, with the choreography pattern is that you have too many small building blocks that need to talk to each other. So you not have the integration between 3 or 4 large applications, but you have very, very small ones. And in this case, you might come back to a spaghetti architecture where everybody talks to everybody, and people need a lot of domain knowledge and process knowledge in order to do the business purpose of the whole application. In such a situation, you might want to introduce a so-called orchestrator. And this is an orchestration pattern as a difference to the choreography pattern. In such a scenario, things would work slightly different. So we would use publish subscribe here rather than the router, because the knowledge of where messages should go is not necessary on the broker. The broker can be completely dumb because the orchestrator will take over to manage that. And the orchestrator is really a workflow engine that knows exactly the process, but it doesn't know the interior logic of these individual services. But as a building block, it makes sense to make sure we have events and messages flow. So you could build it in a way where you say the orchestrator will now subscribe to the order created event, and the payment service will wait for a command. And now you listen up again, right? You see, oh, wow, command. Did we say that's bad and that's not event-driven? But if you have an orchestrator, it is really the building block that needs to trigger and invoke things, right? So having a command in this place is necessary because it will not be possible to have, or you would create a different type of coupling if you would have the payment service wait for some sort of event like orchestrated. And you will not want to bind the payment service to the order created event because that's precisely the point of decoupling order from payment. So what would happen in such an architecture is that you would send the order created event from the order service, and it would be picked up by the orchestrator rather than the payment service. And then the orchestrator could send another message, which then in this case could be a command, and then the payment service would be invoked. Right? So this is different to the very first image where you saw direct command from the order to the payment service because order then needs to know what payment does. But in this case, orchestrator can know that. You could even go so far as to say, why should orchestrator send a message when it knows that it can invoke payment directly? So it could directly go there and invoke something, although again, this is a bit of a temporal coupling depending on the implementation.
We have exactly that implementation on one of our domains.
Okay, nice. Can discuss later. Happy to hear the architectural decision. The most important thing here is that these messages need to be owned by someone. So the semantics of this message, not the structure, because this is imposed by the overall architecture and the broker kind of format, but the message semantics itself would be owned by the individual service. And this is true for event messages that tell something about the past and are emitted by the service, and also messages that are incoming where you want the service to do something and then to take over the process flow. Okay, so if you have some experience with EDA, probably a lot of that has been familiar to you. For others, it isn't, and I will now show a bit more concretely, speaking about micro frontends, how to implement this in the front end. Okay. And the kind of extra here is I will not use any sort of framework, so all that you will see in a second is entirely frameworkless. We are using native web components. Anybody worked with custom elements or native web components? Yeah. Okay, nice. Okay, so let's have a look. Now, code. Finally, some code on a dev conference. So this is a simple web page, right? It's code, but not super exciting. There are some micro frontends hidden here. Where are they? They are hidden in those lines over there. So in line 7, 8, and in line. Okay. So the micro frontends are actually just 2 lines each. In this case, so it's a custom element with an attribute. Can you read this? Yeah, okay. So there is a piece of JavaScript that loads them. You could build this thing in a very different way as well. It's not saying that this is the only way to build these things. It's just to make it very obvious what happens here. So if we found those micro frontends, you see here these each 2 lines of code. And I will go on the right-hand side, you will see the communication that happens between them as we dive deep. But before we will look into the communication patterns, we need to have a look at the micro frontends themselves and what they offer when we talk about an event-driven architecture. Because web frontends are highly event-driven or can be highly event-driven. If you use a state machine, of course, then you have more of a shared state, but this will also emit state changes which are kinds of events. But you can even do it without a central state and fully decouple them from that state by just tossing events and having them orchestrated. And let's have a look into one of those web components or custom elements, how they are implemented. So the first thing you see here is this line that basically defines or registers the web component. It is using the custom elements define API, again, native browser API, and it will pass a class that derives from HTML element. And this is inline. You could, of course, also have the class declared first and then registered in the second call. That is perfectly fine. But now if we look into the body of that class, we see several things that we need in order to have this run in an event-driven way. So the first thing we see are two methods. So the first one is the methods we observe statically. So we register what methods we're looking for. In this case, it's language. And in the second one, we can react to changes at runtime. So the first is a static one because it's at declaration. And the second one will happen whenever those attributes are changed through events. I did not implement them here because we don't have space for that, but you can imagine that we can change things in our state and the representation of that state as those changes come in. Now, a second noteworthy part that has not necessarily something to do with events, but is the actual kind of UI, is here in the where we override the inner HTML through Shadow DOM. Right? This is mainly an encapsulation thing. We do not want to write into the main DOM of the page. We want to have strong encapsulation because having that ensures that we're not messing with the outer environment and the outer environment doesn't mess with us. Of course, there's still ways to do that, right? So if we can build those bridges, but we will later see why we want to prevent them. Now, this is the visual part of the implementation, but there's also the event part. And this is where we could listen to the elements we have just created and say whenever some change happens here, we can then emit maybe our own event for that, or we can have an internal state change. In this case, what we do is we will emit an internal event, and then this could be, for example, when the flight has been searched, we could say, okay, the flight has, or the form has been changed in a way that we can now go and create the results for that. Okay, so this will just say, I need to go from this airport to that airport with those many people at this time and date. Okay, and this would be the object that is being emitted for the search form. All right, now going back to our web page, we see that we would set the language attributes as the first and initial attribute. And this can happen even at render time. So you can deliver that from your server or from your CDN to the web page. It doesn't need to be injected later on. And for purposes of SEO and faster load on that already pre-renders some of the either layout properties or just as a placeholder to not have that flickering that would give you poor core web vitals, right? So, but it's just initial configuration. And now what happens when we interact? We leave the logic of the search form to the search form itself. We do not care what happens inside it. This is just the orchestrator here. And the orchestrator cares about when something's being emitted. And this would be an event that says, I have the search form has been submitted with those and those parameters, and then the orchestrator, or here the integration layer, that should be orchestrator, is then able to react on that and propagate the event or transform the event and then propagate it or create a new event to then trigger or invoke the result list. Okay, and this is what would happen then. Whenever a search is being triggered, it goes to the orchestrator, and the orchestrator can then change the state of other microfrontends programmatically. So it will do that in a declarative style. It will not tell the search form to go search. It will just say, look, here's your new configuration. And the configuration for you now is these many people, these airports, this time and date. And this is then through the observe attribute and attribute change callbacks that we've seen earlier, would allow the micro frontend to reload its state and go to its API, search for flights, and bring them up again. Okay, and this is why it's strongly decoupled from both the state as well as the search form. It's completely autonomous. Whenever you inject a new state, new configuration, it will change its own state. You can, of course, implement the MFE2 also in a way that it would accept some sort of event, right? Because we're using native event mechanisms here. That is the CustomEvent API that you have in every modern browser these days. I'm very happy that we don't have to debate Internet Explorer anymore. So all these APIs are solid and present for everyone. So what happens when we change those programmatically is really that, and you can really see this when you look into a developer console, is that the resultless micro frontend will get those new attributes and evoke the change. Okay. So we have now seen how we can have this interaction strongly decoupled between the search form and the result list through the introduction of an orchestrator who would then make sure to catch events and propagate them to the next micro frontend in a declarative way, or if you want, you can also send event. You can abuse the event API to send commands, right? It technically is possible. It's a matter of your governance, how you set this up. And this brings me to the next point. And this is about introducing something that sets rules for these things, because we all meet in a browser, we all meet in a web page, and we all know how to play dirty tricks and have our little list of hacks in the drawer. So that can be helpful sometimes, but at the same time, we have to make sure we're not breaking boundaries that have been intentionally placed in order to have a solid architecture that will allow us to deploy things independently without worrying about coupling to others. Right? So what I would propose now is a standard or a kind of a little mental model framework called OpenMFE. This has nothing to do with Amazon, right? So this is a little open source project that I've been involved with. And it solves the problem of governance and tooling in such an architecture. Because again, technically speaking, you can do a lot of things, but you shouldn't. So let's see what OpenMFE can do for developers. First, it has a specification, and the specification is a document that governs what you can and shouldn't do in such an architecture, and we'll look deeper into this. It will also give you interface contracts, and when I say contract, I mean API contracts. So probably all of you have at some point written Swagger or OpenAPI documents, and this is from the perspective of what you offer to the outside world, a contract. It should be, right? It should be you should have the mental model of abiding by the structures that you have published there. You should make sure that the specification matches the implementation, things like that. And this is a contract. When you break the API, release a new version and keep the old one stable, talk to your consumers when you need to decommission an API, that is the notion of a contract, maybe even non-functional requirements, SLAs, that is all part of this contract. Now there's also a bit of tooling. Very honestly speaking, more in a prototype or early stage phase where you would say, I need to validate those contracts. I can use automated testing to make sure that I have the specification itself semantically valid. And it would also give you some tooling to runtime test against the provisions of the runtime governance. And there's a bit of documentation with best practices as well on the website. Now let's come back to the runtime governance, and regardless what kind of micro frontend flavor you take, you do it natively or with React or something else, you will always face a situation where some smart developer says, yeah, I'm running in a browser and I can fully access the DOM of my parent page, so why not do that? Why not take a shortcut? Why not say, I want to inject some CSS because I cannot do this from within my micro frontend. I'd rather have it loaded on the host page. And what then happens is, of course, the CSS applied globally because forgot namespacing happens, right? And so you are messing with everybody else's micro frontends or even the layout of the host page. And this is why technically things are possible, and we have those kind of side channels that would allow us to do them, but we need to prevent them. And because it's not technically possible to prevent them, because they are in every browser and you can always find a way to do that, unless you go to extreme lengths, we said we will address this at the governance level. So have a documentation that says, okay, this is how you should build it. To some extent, we can test it to make sure that, for instance, you aren't breaking this boundary by injecting CSS in the host page. But mostly this is an appeal and documentation for developers to say what's right or wrong. So we'll prevent the side channel activities and ask developers to avoid this as well. And what we've seen is that you will really have a very independent development. If developers understand this, they will not get into each other's turf. They will face some challenges like loading fonts from within the micro frontend is very fun. But it's possible and always better than messing with the host context.
Everyone's thinking we have that shit.
Everybody has it. Okay, so this has been the governance part. But when we look at the specification part, it's also interesting because in the end, when we talk about APIs, events, and so on, this is very similar to what we see in the back end. And there's some very good patterns there as well. And when you see this, you may think of OpenAPI immediately, and it's heavily inspired by it. We wouldn't use OpenAPI directly because it's more around resources, objects. It can also serve events for event-based communication. But we need a few other things here as well. And so we developed a format that is also YAML-based. We'll also use JSON schema for, schema of attributes and events. But if we go one by one through this, this is a document that first will start with some meta information like the name or a bit of description, because it should also serve the purpose of generating documentation automatically. In the end, it's not enough to create 1 million micro frontends and place them somewhere, but if you have really a distributed architecture with autonomous end-to-end teams and some other team needs to integrate that, they need very good documentation on what this micro frontend does, what it's supposed to do, who to reach out in case of problems, non-functional capabilities such as response latency and so on. So this is in this meta section. What's also important is that you have the fundamentals, like from where can I load this micro frontend and what is the tag name for this micro frontend. But then already we go into attributes and events. And this is the part where you would lay out through JSON schema, one by one, the attributes that you have and the events that you are intending to emit. So when it comes to attributes, obviously you can choose any kinds of attributes in a custom element. Except for some of those are reserved and global in the HTML specification. But for the most part, you can choose, I want this to represent the logic of my domain, right? So in this case, it could be airports, people again, when we stay with the example of our search form. The important thing here is when it comes to schema, this is JSON schema, and any micro frontend can use its own manifest to validate incoming communication. So this is a chance for a developer to make sure that the spec in this case is consistent with the implementation. So it's very valuable to write this document early and then make sure that you validate your own communication against what you have specified. When it comes to attributes, by the way, some things I hear objection that says, yeah, but attributes can only be scalar values. And we have built this in a way to say you can specify an HTML attribute in a way that it appears to be a non-scalar value, such as an array or an object. And in the implementation, you would simply use a serialized JSON string. So we extend the capabilities of the HTML a bit through this convention of accepting JSON here. Okay. And finally, we will also give some, we'll also give some examples at the bottom. So this last 5-ish lines is again into the documentation, automatically generating something that people can interact with. So you can say, here's an instantiation configuration that you can just launch and try it out. This is also very helpful when it comes to automatic testing. So you can launch a micro frontend somewhere in test environment and build a test against it based on this example configuration that it has shipped intrinsically. Okay. Again, there's a bit of documentation, so feel free to check the website and have a look at the repository. There are some code samples that will show how this works in practice. Now, what's all the purpose of this? Because we have seen that many organizations use micro frontends in a very different shape or form. There are frameworks particular for micro frontends, either for the orchestration and integration at the host level part, or for building the micro frontends themselves. But the very important aspect of going to micro frontends is modernization. So I've been in an organization called TUI, and the challenge we had is modernizing a legacy website that has been built in a monolithic way, back then in Angular, and you can still see some remains if you go to tui.com these days. But more and more it has been incrementally modernized. Because you can say the perfect microfront architecture is this and that, and draw something on a whiteboard and start on a green field, but the reality of enterprise software is that you're not starting on a green field. You have to start with what you have. It has immense business value, so you cannot go to your manager and say, yeah, let's throw everything away and start from scratch with this shiny architecture. And the reality is you shouldn't. As a diligent developer, you should never throw things away that work, because who tells you that the things you have no idea about and just read a book about are going to work perfectly right away in an enterprise context? So this is a plea for an incremental modernization using micro frontends. And what we can do, because this is browser native technology, we can simply say, well, simply, it's still a lot of work and a bit of risk, but you can start with a legacy website and say, okay, at some point in the future, we want to have a different website, probably also different layout, although this doesn't come across in this picture here. But the idea being you can modernize without having to already know or perfectly build the target state and then throw the old thing away and start a new one. So the way you could do that is by saying, okay, in our old architecture, in our old application, we have building blocks that we can carve out. And we will re-implement them as micro frontends. Right? And we can do this with those standalone mini stacks we've seen earlier in this presentation. So it doesn't have to be integrated with the deployment mechanism or the infrastructure where it runs, but you can simply have a little JavaScript that you place in the position where you need it to happen and have this native web component placed below that or above that, because it will then automatically load at this point, and you don't need any other frameworks, integrations that might conflict with the already running frameworks that are in there. But you can also, in the next step, say, we can start designing, building a new thing. We can start building micro frontends just for the new website. We can start building a new website itself. It should be fairly straightforward because it doesn't have a lot of logic. The logic is in the micro frontends. And then this is also much lower risk in saying we will build something new, because you can use the building blocks you have created in the meantime to get the look and feel of the new website. And because these are autonomous building blocks, you can also evolve them with time. You need to be careful of APIs, obviously, again, because every micro frontend has those message patterns and all the things we've seen in the manifest. But if you release different versions on breaking changes, you should be fine. You can have a micro frontend XYZ in version 1 or 2 and say, okay, this is just a minor variation and there's not much overhead in running both. Okay? And before you know it, you have built your new website out of the new kind of host environment or app shell, and you can reuse a lot of those micro frontends or you build new ones where you need them. Okay? So this is an approach in a nutshell that you could take if you're modernizing a large enterprise application. One important thing here is that when you do that, and it's not a big deal, but I want to emphasize it, is you should have UI library. In a distributed front-end architecture, really spend some time to building a good UI library with the elements that you need for the frameworks that you use. If you happen to use multiple frameworks, make sure that it's well documented. So use something like Storybook to have, again, a visibility and documentation of those. Set aside some people who do that, because I've seen organizations who do that in the side and have very immature UI libraries, and they don't have the elements or the color schemes that all these micro frontends need. So everybody goes away and creates their own style. It takes more time, and it just looks inconsistent, if not to say, some swear words, what it looks like if you not have the mature and solid UI library in place. All right. So this has been a walk through different aspects of how to build micro frontend architecture in an event-driven way and with native web components. I thank you very much so far. Hope you enjoyed it. Thanks. Any immediate questions or challenges?
I just wanted maybe more information about, does the OpenMP spec specify versioning, and how would that work in practical terms?
No, it doesn't. So this is in the documentation as a suggestion. You should do that just as I said now, but it would expect that you release a new version yourself and then do your thing there as well.
So like in practical terms, if I needed like a breaking change, that it would essentially be described by a new sort of spec with a different tag. Is what I'm sort of
Exactly. You would fork the repository and then rename the components so you don't collide. Somebody could have result list v2 or something in the name, and then you do just a normal thing.
Can you tell us about the tooling around the spec? I would love to hear what you've done so far with it. Documentations maybe, or
Documentation, well, yes, a bit. So the tooling is, there are two little tools. It's just more of a demo what you can do with it. And one thing is a schema validator. So in the manifest document you saw a lot of things that are, I would say, nice to have, like documentation bits, but some are really the interface contract, like the attributes, the tag name, and so on. And this one checks your manifest if it's complete, but also it can do, if you change the manifest, it will show you breaking changes. Right, so to answer your question as well, you can run this every now and then or in your CI/CD pipeline, and if it sees that there is a change in the parts that are the interface contract, it will alert you and throw an error. And there's also something that launches a Puppeteer instance in order to do runtime checks for those governance bits I meant. So it will create a dummy HTML page, instantiate the microfrontend in it, and then see if it does a few things with the host environment. But this is not really evolved, it's just more of a demo.